Good morning, everyone. Welcome back for this energy and data and modeling program by the IEA. As you know, today is the 13th webinar of this series. We will not be touching theoretical aspects. We won't have, let's say, a webinar as we had in the previous time we met. Today is just a wrap-up quiz and closing session. So I just wanted to give you a brief recap of what we, sorry, I see in the chat. Can you hear me now, Marceline? I hope everyone can hear me. Okay. Yeah, maybe it's a problem from your side, Marceline. Write in the chat if you're still not able to hear me. Thank you. Okay. Okay, perfect. Thank you. So today is, as I said, a wrap-up quiz and closing session. So I will start with a brief recap of what we've seen till now, first with my colleague Zakia and then with me. And then we'll move basically to a Menti. So if you remember Mentimeter, Menti-based session in which we will be asking you some questions which are related to the topics that we addressed during the webinar. So just to recap, this was our agenda. If you remember, we started clearly with an opening. Then we had you had 4 webinars with my colleague Zakia on statistics. So you started with the introduction, then you had a lecture on statistics by commodity. Then you moved to the energy balances and the CO2, and then finally with the prices and taxes, and in particular energy efficiency indicators. Then we had the modeling session in which I started with the introduction. Then we had the energy demand oriented lecture with a specific focus on the building sector. Then we had power sector, the hydrocarbon supply, and this was, let's say, the core of the modeling part. Then we had 2 webinars with 2 partners from the academic world. First, we had from Italy, Politecnico di Milano, and then from the UK, we had the Imperial College. In both these sessions, if you remember, our partners presented you their approach to modeling and how they use modeling in real-life case studies around the world, and in particular in the African continent. And then last week, we had 2 lectures, one focused on SDG 7, in particular on access to clean cooking and electricity, and finally on final lecture with about solid biofuels estimation models. So as I said, today we'll be focused on all these topics. Basically, we will be presenting you some questions from Menti so that we can have a grasp of what feedback from you on the webinars, etc. So just to recap, these are more or less not all, it's not exhaustive, but the core of people you met during this webinar. So we had the lead team coordination and teaching. So as I said, Zakia, which led the statistics part, which unfortunately is not here with us today. Then I led the modeling part, and then we had Marina, which is always connected and which is in charge of the organization of the whole webinar. We had different experts. You had, if you remember, Taylor for statistics specifically on Africa, and she will be with us today. She's already with us today, actually. Then we have the Africa desk, which is in charge for the support and engagement. So you had Arnaud, Cyrine, and Rita. Just to remind you, this part, which was virtual only, is basically phase one of our program. So we had 25 hours of live interactive webinars, which had, let's say, as goal, teaching the basis of both statistics and modeling. But this is, again, really just phase one. If you remember, we had 10 countries which are involved in the whole webinar. So after you, we will be finishing with Rwanda and then Uganda. And then it will be, let's say, over for phase one. Then we will move to phase two, which clearly we have to see a bit what will be the policies related to travels in the pandemic we are still living in. But the idea of phase two is to be in country, so with practical sessions of 2 or 3 days, like of really practical work. And the idea of these sessions is to tailor the these practical sessions with country specific exercises. So to understand country by country, which could be the best approach, which could be the best topic or the best topics to address during this section. Then we will have an advanced work over, let's say, a quarter with remote support from us, from Paris, in which the idea is to have a practical project on which you will be working on, which will be both on modeling and statistics, but again, it will be, let's say, country specific. And then we will have on a regional base, so for regional groups, we will be like you will be, let's say, presenting your projects. So there is this phase which is called project restitution, and then additional training, again, really targeted and country specific, depending, for example, of the kind of projects each of you selected. And then there is still to be confirmed, again, as you may imagine, there is a lot of uncertainty when we talk about moving people, but there is, let's say, a workshop in Paris which is supposed to happen at the end of the overall program, so that in which we will have additional trainings and, let's say, with selected experts from all countries. And in this workshop, we will also be basically closing the overall program. You can see how the I don't know if you see my pointer. The overall phase two is supposed to go through mid 2022 to mid 2024. Probably it will start. Probably not mid 2022, maybe the third quarter of 2022. But again, you will be receiving information as soon as possible, depending on policies on traveling, etc. I remind you, we have like the goal, another goal, a side goal of the program is to create a community of practitioners. So we have this LinkedIn group in which all countries are regrouped. So you will also have the opportunity to interact with your peers from other countries, from the other 9 countries which are part of the program. The idea is also having a continuous collaboration on energy data. So if you identify, for example, specific topics which were addressed during the webinars and which are synergetic with what you do in your daily work, and in which we think we could support you, do not hesitate to mention it to us, to write us an email and to propose, so we can address the topic and see what could be the best manner to address each specific issue. We already had some of the attendees from the webinars, which, for example, contacted us to see how we could support them in the data collection, for example, process, for example, for the consumption at the residential level. So in order to see surveys and, for example, which kind of data it would be interesting to collect, and how, for example, to prepare this data collection process in order for it to be also suitable for modeling in a second phase. So that's it. I will, let's say, thank you later, let's say, but so we will move now to the menti.com platform so that we can have the questions. So I leave the floor to Taylor, which will start with the questions related to statistics. Hi, Taylor.
Hello. Good morning, everybody. Okay, so you should be able to see my screen now. Please go to www.menti.com and we have the code 12605060. So I can put that in the chat. Okay, let's get started. So to start off, we'll have about 13 questions on the energy statistics part of the webinar. And then Darlene will take over for part 2, which covers modeling. So first question is based on the international recommendations for energy statistics. So we include in the national energy statistics and balances the amounts of, and then select all answers that apply. So there are multiple correct answers to this statement. So please select all that are true. So I'll give you about a minute to choose your answers. Okay, we have a couple answers coming in. Okay, so the correct answers here were natural gas used for heating, fuel wood burnt for cooking, and natural gas used as ammonia feedstock. So the different energy products and flows and what should be included in the national balances. So the scopes and boundaries of energy statistics are all described in the international recommendations on energy statistics. So I encourage you to use that document whenever you're unsure, and it's a very useful tool in the field of energy statistics. So moving on to the next question. So what is an example of how wood is used in energy statistics? So there's only one correct answer for this question. Okay, I'll see. We have a couple answers so far. I'll see if we have any more answers to come in. Okay, so you have the correct answer here. So an example of how wood is used in energy statistics is burning for home heating. So in this example, we have energy that is produced and captured and used in a productive way. So in energy statistics, there are a variety of different solid biofuels that we collect data for. However, it's important to note that only the amounts specifically used for energy purposes are included in the energy statistics. So for instance, wood used for furniture making or for building houses, it would be outside of the scope of energy statistics, and that data does not need to be included. So moving on to the next question, which renewable energy source do you think takes the largest portion of global electricity production? So I'll give you a minute or so to answer this question. Okay, it looks like everyone about has it. So yes, the correct answer here is hydro. So we can see in this graph from 2018 that coal and natural gas are the largest fuels used for electricity generation. But for renewable fuels, we can see that hydro is the largest at 16%, and all other renewable sources combined make up only 10%. So hydro is the correct answer here. So next question, what is the largest energy consuming sector in the world? And to give you a hint for this question, you can select multiple answers here. Okay, a couple more seconds for last answers. So the correct answer here was transport and industry. So the reason we have a tie is in 2018, transport and industry were about equal in total final consumption in world at both 29%. So what is the largest energy consuming sector in Africa? Okay, a couple more seconds for last answers. I see a lot of you have selected residential so far. And you are correct. Residential is the largest energy consuming sector in Africa. And we can see that it has quite the majority, 54% compared to the next largest industry, which is transportation at only 20%. So next question is, which of these regions has the highest share of renewable energy, including traditional use of biomass, in their total energy supply? So your options are Africa, Latin America, and Asia. Okay, a couple more seconds for any last answers that need to be submitted. I can see that most of you have chosen Africa for this question. And you are correct. Africa has the highest share of renewable energy in the total energy supply. And this is because of the large share of solid biofuels in Africa's total energy supply. So we can see that all renewables make up about 50% for Africa of the TES. And then this is followed, the next largest region would be non-OECD Americas with 33%. And from the previous question, which covered total final consumption by sector, a large portion of total final consumption is also solid biofuels, which is used for residential heating and cooking. So now we will have a couple questions that focus on the energy balance, which you should hopefully remember from the first two sessions of this webinar series. So these questions, you'll find that we have multiple questions on this balance because it's an important tool and there's a lot of information that can be gained from a good energy balance. So it is important to be able to understand the different concepts and how the data can be used to convey information here. So the first question on the energy balance, and in this case, we're just using Nigeria's 2017 energy balance as an example. So is the country an energy producer? And if so, what products do they produce? So this is an open-ended question, so you can type your answers. And they will show up on the screen here. Okay, I'll go back to the balance so that in case some of you can't see. So please keep submitting your answers. Okay, a couple more seconds to submit any final answers for this question. Okay, so it seems like many of you have got it. So the answer is yes, indeed, Nigeria is an energy producer, and we know this because we can look at the production line of the balance and see that in this case we have many products that are produced. So a small amount of coal, a large amount of crude oil, some natural gas, as well as renewables such as hydro, geothermal, solar, and other renewables, and biofuels and waste. So now we're continuing to look at the same energy balance, but this is a different section of it. So now we're looking at the total final consumption. So based on this example, what is the largest final consumption sector? And again, so this question is multiple choice. And your options here are industry, transport, and other. So I will go back to the balance. Okay, a couple more seconds to submit any last answers. Okay, so a couple of you have chosen other, so this is correct. So now going back to the balance. So the first thing to look at here is we're not looking for any specific products. We're looking at the total final consumption. So that means we need to look at the total column. And then as opposed to the last question where we wanted to look from left to right to see which products were being produced, in this case, we need to look from top to bottom to compare the different sectors. So they're divided into industry, transport, and other, and we can see conveniently these are bolded, so we can see that other is the largest final consumption sector here. And this is because it includes the residential sector. So we can see of the subsectors, residential is by far the largest here. So the correct answer was other. So again, we're still looking at the balance. This time we're looking at the transformation sector of the balance. So what is the difference between a negative number and a positive number in the transformation sector? So this is an open-ended question, so please type your answers. And I'll give you a minute or so. So this is an important concept in the understanding of the energy balance format. And it's important to be able to read it correctly and interpret what is going on in the transformation sector of a country. Okay, so a couple more seconds to submit your answers. Okay, thank you very much for your answers. So yes, you are correct. Negative, in this case, I will go back to the image. So a negative number in the transformation sector means input to transformation. So you can think of that as energy being consumed for transformation. And then a positive number means output in the transformation sector. So something is transformed and produced. So for example, we can look at the row for electricity plants, and we can see that under the product natural gas, we have a negative number here, negative 5,733. So this means that natural gas is being used by electricity plants and is being transformed. And we can see in the electricity column that we have a positive number here. So electricity is being produced. Now, an interesting thing to note for the balances is that we also have this total column. And this total column can be used to determine the losses within transformation. So we can see for electricity plants, we have a negative number here. So that means energy is lost through this transformation process, which we would expect because we can't have 100% efficiency when in transformation, or at least for electricity production. Similarly, another important transformation process is oil refineries. So in this case, we see crude oil is the input to transformation, it's negative here. And then oil products are the output, and they are positive. So their output, and then in the total column, we can see a negative number. So there are a small amount of losses in this transformation process. As we would expect, we would not want to see energy gains here because that is impossible. So this is our final question on the energy balance. So this is the energy balance of an unnamed country. So you need to determine which country it is. So your options here are Algeria, Ethiopia, and France. So looking at what you know about these countries and what you can see in the balance, you can determine which country this balance belongs to. Okay, a couple more seconds to submit your answers. Okay, so we can see that most of you have voted for Ethiopia. Thank you everyone for your answers. So the correct answer here is Ethiopia. So going back to the balance, so there's a couple of clues here that could point you in that direction. So first of all, we can exclude France. And one of the reasons why is France has a large portion of its electricity production is from nuclear. And we can see that there is no nuclear production here. So we know it's not France. We also know that it's not Algeria because Algeria is a large oil and gas producer. And we can see that in the production row, we do not have any fossil fuel production. So that is a clue that in this case, it's not Algeria. So by process of elimination, it is Ethiopia. But some more information that would help you identify this as Ethiopia is we have a large portion of biofuels and waste production. And also there's a large amount of hydro production. So Ethiopia has a large share of hydro in its total energy supply. So this would be a sign that this balance belongs to Ethiopia. Okay, so moving on to the next question. This question and the following questions concern the emissions portions of the webinar series. So Africa accounts for what share of the global CO2 emissions? So our options are less than 5%, between 5 and 10%, and more than 10%. Okay, a couple more seconds for last answers. Okay, indeed, the answer here is less than 5%. So looking at CO2 emissions by region, we can see that Africa is actually about 4% as of 2018. And it is the second smallest emitter, smallest being non-OECD Americas. So next question, what percentage of global CO2 emissions from fuel combustion in 2018 comes from coal? So is it 35%, 45%, or 55%? This question is a bit tricky as the different options are quite close together. Okay, a couple more seconds for last answers. Okay, thank you everyone for your answers. The correct answer here is 45%, and many of you got it. So we can see that coal in 2018 contributed to 44% of emissions from fuel combustion, followed by oil and natural gas. So this is the last question in the energy statistics part of the quiz. So countries representing approximately what percentage of the global CO2 emissions from fuel combustion have already pledged net zero emissions? So a key thing to note here is already pledged, so this would not include countries that have, for instance, pledged and then have changed that pledge. Okay, a couple more seconds for final answers. Okay, so the correct answer here was around 50%. So looking at this graph, we can see that approximately, well, actually a bit over 50% of countries have pledged net zero emissions. And it is important to note that this graph does not include the United States. So if it did include the United States, that would be about 65%. So that concludes the energy statistics part of the quiz. Thank you very much for your attention and time today, and I will hand it over to Darlene to take over for the modeling part of the quiz.
Perfect. Perfect. Thank you very much, Taylor. I will continue actually with the same presentation. So just tell me if you can see my screen. Sorry, Taylor, I need you to close the Mentimeter so that I can use it, because otherwise I can't present. Okay. Okay. I see there is a question actually. I don't know if. Okay. Yeah. Sorry. Okay. You should be able to see my screen. Perfect. Thank you. Thank you very much again, Taylor. So we will go continue with part 2, which is focused on the modeling part, and it's again the same structure as the quiz you just did with Taylor. Sorry. Okay, so the first question is which bar represents urban population growth of Africa between 2018 and 2040? Which one between these three? So pay attention to the years. So we are talking about a forecast in terms of population growth between 2018 and 2040, because this is the result of modeling exercise we did a few years ago. So do you expect the Africa urban population growth to be the yellow bar, the purple bar, or the red bar? Which is like, wait. Okay, I see 3 answers. Okay, 5 answer. I see the majority is on the red bar. Red bar. So let's see the correct answer. It was actually the red bar. And you can see it from this chart, in which you can see how Africa population, in terms of urban areas, is expected to grow of approximately 600 million people from 2018 to 2040. And the other 2 bars were China and India, but China was in the 2 decades from 1990 to 2010, and India is again a forecast. So you can see also the cement demand in the same chart from our Africa. Sorry, this is the World Energy Outlook. You can see how, for example, the cement demand in China in these 20 years of great urbanization went skyrocketing, and this is what we expected, for example, for India and Africa in the next 2 decades. Let's continue with the next question. So this is historical and projected primary energy demand. Which number is South Africa? Number 1, number 2, or number 3? So here you have the historical and projected primary energy demand. So I would like you to tell me which of these 3, because we are talking about 3 countries, which of these 3 countries is South Africa from your point of view? I see 3 answers. Four answers. Give you a few more seconds, and then we can find out which of these is actually South Africa. I see there are people which just joined actually. So I will send again the link in the chat and the code so that if someone just connected, you can join us on menti.com as usual. Okay, so the correct answer, sorry, okay. Sorry. Okay, the correct answer was actually number 3. So you can see it from this chart. The first one was Ethiopia, which has this growth in like because we are talking about the stated policy scenario. So this is like the first two bars of each country are historical data. On the other hand, we have 2 years, which are projections, which come from our modeling from the stated policy scenario. So we have Ethiopia, in which we can see this growth and this diversification also from bioenergy, but with bioenergy, which is still very relevant. We have Angola, which is also increasing, but because you have also to look at the mega TOE. So it's not just the trend, but also here we have that Ethiopia will reach approximately 80 million TOE in 2040. Angola is not even reaching 30 million, and on the other hand, we have South Africa, which has very high energy primary energy demand, but which is almost constant. So these were, let's say, and also the fact that they are heavily reliant on coal, which was another indicator that you could have used in order to spot, let's say, South Africa. But most of you got it right, so glad to see that. So next question. So this is historical and projected primary energy demand for sub-Saharan Africa under 2 scenarios. Which number do you think is the Africa case? So I won't remind you what is the Africa case. Try to remember what we said. We have usually used 2 scenarios. One was the stated policy scenario, and the second one was the Africa case. So which of these 2 do you think is the Africa case? Again, we have 2 bars, which are historical data, so 2010, and 2018. And then we have 2030 and 2040, which are in both cases the result of modeling exercises, but with very different assumptions. So I see one answer. Oh, sorry. Sorry, I have an issue. Sorry, I have an issue with, okay. Okay, so we had 3 and 3, so ex aequo, but the correct answer was actually scenario like the second chart on the right. And you can see it from, like you could have used different approaches in order to spot what was the Africa case. I remind you, the Africa case is our modeling scenario, which takes into consideration the goals of the Africa 2063 agenda from the African Commission, the African Union, and what would have could have helped you spotting the Africa case is the fact that you have here the GDP, which is on the right X and is this orange point, which in the stated policy scenario reaches approximately $10 trillion. But in the Africa case, we have a GDP which is 60% higher than the stated policy scenario. And this is because in this scenario, we expect Africa to have, let's say, a brighter future in which we have drastic improvement in terms of socioeconomic well-being. But I remind you a very interesting fact is that although we are talking about higher GDP, so someone would expect higher primary energy demand. In this case, because we anticipate in this scenario higher efficiency in terms of primary energy demand and lower, so a huge shift from traditional biomass, you can see how the total primary energy demand is lower than the one in the stated policy scenario in 2040. And you also can see how the green bar, which is bioenergy, which the vast majority is traditional biomass, is very low compared to the stated policy scenario case. And you can see how, for example, renewables have higher share. We have gas, which also is has an higher share. So very diversified primary energy demand in terms of sources and higher GDP. So here are the mix evolution in various regions. The legend is the breakdown by fuel is missing. Associate each color, so each number, to the right fuel. So if you can see from this chart, you have 1, 2, 3, 4, 5, and 6, which are 6 different fuels. From this chart, there is no fuel. Sorry, there is no legend, so you can't know which is the fuel. But we ask you to try to guess. If you remember the charts, also try to deduct which for each of these 6 colors, which are 6 fuels, which is each of them. So you have in this chart China historical data, because we have from 1990 to 2005. We have India, which is again historical data, because we have 2000 till 2018. And then we have both cases for the Africa, for modeling for the Africa future, in terms of, so this is for a model, the result of modeling. On the left, you have the stated policy scenario results, and on the right, you have the Africa case. This is from 2018 to 2040. So the left chart, so the colors, the colored bars are in mega TOE, so megaton of oil equivalent. On the right, you have grams of CO2 per GDP in terms of dollars, and this is the, let's say, the orange point, and this is the carbon intensity basically of each of these economies. Okay, we have one answer. I don't see any additional answer. I see, yeah, I know that's a bit maybe longer to answer to this question, because you have to select each single color. Okay, 2 people voted. 3, okay. Few seconds more and then I will show you the answer. Okay. Okay, so this is what you answered. Okay, I see an additional answer. Okay, so this is what you answered. You have all these colors, so it's a bit okay. So here you can see which colors we were talking about. So starting from the top, we had the blue, this dark blue, which is nuclear. Then we have renewables. Then we have natural gas, which is the red one. Then we have oil, which is the brown one. We have coal, and here you could have spot this because we know that China is heavily, has been and still heavily reliant on coal. And then you have biomass. For example, biomass, you could have it anticipated because you can see how in the Africa case, as I told you, there is this shift from traditional biomass to, let's say, improved and higher efficiency technologies. But so you can see this shift. So you could have identified the difference, let's say, in the future of Africa between steps, the step scenario and the AC Africa case scenario, because you have, for example, this huge shift. Okay, so let's continue. So final energy consumption projections are different in the steps and AC scenarios. What parameters can lead to upward changes? So purple bar. So you have the steps and AC scenarios which have okay. You have the in this case the step scenarios and the AC scenarios. In both cases, you have both fossil fuels and electricity. In this case, we just took Ethiopia, for example, but you can do it for whatever, like the vast majority of the countries and the entire region. I'm asking you this purple bar, so this upward change, to which parameter we can which parameter lead to this upward purple bar, which this arrow, which is upward oriented. So this means, if you remember this chart, sorry, this chart, we move to the steps, which has this level of final energy consumption in 2040, and we have this total final consumption in the Africa case. I remind you the difference, the stated policy scenarios is that scenario which takes into account all the stated policies of all countries around the world, and in particular in this case on the African continent, and model them. So model the entire continent energy system based on these assumptions. In the other case, we have the Africa case, which is aligned with the Africa 2063 agenda, which has different assumptions, which, if you remember the assumptions, you should be able to get why we have this upward change, so the pink bar, and why we have this downward change, which is the blue. But in this case, I'm just asking you to tell me why there is this upward change. So why is there a higher final energy consumption in the Africa case if compared to the stated policy scenario? I see 2 answers. Okay, I see 5 answers, so I will go to the solution. Okay. So you had more energy efficiency, higher GDP, lower urbanization, and more people with energy access. So, sorry, the correct answer was the higher GDP and more people with energy access. So we had 2 answers, and you can see how moving from what is the stated policy scenario, so what governments around Africa in this case, but in this case it's just Ethiopia, committed to achieve, let's say, from here to 2040, if they had, let's say, to achieve what is stated not in their policies, but in the ambitious Africa 2063 plan, you would see a huge shift in terms of final energy consumption, like from more or less 13 mega TOE to more or less 19 mega TOE. But, and this is due first because we have more and more people gaining access to electricity, because, for example, the Africa case has the universal energy access as goal. Whereas on the other side, we have many countries which, for example, don't have right now a universal energy access pledge in the next, like in the incoming years. So this is one difference. But on the other hand, we also have higher economic growth, and which leads to higher GDP. And when we have people with higher GDP, this means that people on average will be consuming more energy. And in this case, we have, and that's why we have, let's say, this upward purple bar, which is then lowered by the fact that we have the efficiency gains, which gave you the possibility to have the same, let's say, final energy consumption. So less final energy consumption, but with the same level of socioeconomic well-being. So next question. In order to limit demand growth from transport sector in the future, which parameters can policies influence? So you have 3 parameters. You have passengers kilometers, efficiency of cars, number of passengers per car, and average age of car fleet. So you can see here the trend on passengers kilometer, oil demand, and average fuel consumption, which can give you a hint of what could be the answer. And here the question is, in order to limit oil demand growth from transport sector in the future, which parameters can policies influence? And if you remember, this is very similar to the first exercise we did in the modeling section, because we modeled the transport sector and we addressed all of these parameters. And if you remember, in the final part of the exercise, there was that sensitivity analysis that gave you the possibility to see which, for example, of these, like what was the impact of each of these parameters on the total oil demand of the transport sector. So I see 2 of you answered. Give you a few, maybe 1 minute, okay. So in order to limit oil demand growth from transport sector in the future, which parameters can policies influence? Between passenger kilometer, efficiency of car, number of passengers per car, and average age of car fleet. So, Okay, another answer. Okay, so all, let's say, all answer were correct. There was no wrong answer, let's say, because all of them are important aspects to be taken into account when you do transport sector modeling. So I invite you to have a look at that, but all of these parameters were important. So to make projection on how energy demand for various needs will evolve, we need to identify activity variable, which is the best for cooling. So you have floor space per household, number of household, appliances ownership, and number of people per household. So which of these activity variable is useful when modeling the energy demand of various uses? So you have cooking, for example, lighting, water heating, cooling. So these are examples of, let's say, other energy, so energy use in terms of needs of, for example, households. You have cooking, in which, for example, the activity variable is the people per household. We have lighting, in which the activity variable is the floor space per household. We have the water heating, in which the people per household is very important, but what should we take into account for the modeling of cooling, like the energy demand for cooling needs? Okay, I see 4 of you answered. So let's see. Okay, we have 2 people which answered floor space per household, and 3 people which answered appliances ownership, so AC units per household. So let's see the correct answer. The correct answer was actually appliances ownership, so AC units per household, because as you can imagine, having, because if you have a big house, you could have many AC units, for example. But so the idea is, in this case, because we are trying to understand the energy demand coming from, for the cooling, you have to take into account the fact that you could have different values in terms of average appliances per each household. And in this case, also the other numbers could be important when you do, so not in the other parameters could be interesting and really important when you do the modeling of the cooling sector in terms of energy demand. And if you remember, we used them in the exercise we did for the energy demand, so lecture number 2. But when you have to find the best activity variable, appliances ownership is the best one. So assuming that ownership rate is the best activity variable and income the best proxy, what type of curve would describe their correlation? So if you remember, when we were trying to forecast, to anticipate the ownership rates of different appliances, but in particular for the AC units for the cooling sector, we have different curves. So sometimes we have a linear correlation, we have inverse curves, we have S curves. So in this case, for example, we have that cooking is best represented by an inverse curve. We have lighting, which is on the other hand represented by the S curve. Water heating, again, is inverse curve. We are trying to see, if you remember, because we touched this topic, because it was part of the assumption while doing the exercise on this sector. Which curve do you think best fit? So there is the best correlation between the ownership rate and the income. Try to remember which shape have had these curves in order to see if they make sense to you. Like which of them makes more sense to you when we try to correlate, for example, GNI per capita, which I remind you is the gross national income per capita, and the ownership rate. Okay, let's see what people answered. So just one thing to remind you, which I didn't mention earlier before the Menti, but I think I've stated that many times during the other Menti polling we did. This polling is completely anonymous, so we don't have the possibility. We can just see how many people answered each of the options, but we can't see which of you answered each of them. So that's I just wanted to tell you. So feel free to answer to select the answer you think is the best one. So going back to this question, the best, let's say, curve, which represents the correlation between the income and the ownership rates in terms of appliances in the cooling the AC units, is the S-shaped function. And if you remember this is really interesting because this is a really important chart, and you can have a look at it in Teams. If you remember, my colleague Tim gave you a very interesting presentation on this specific topic. So if you don't remember it, I invite you to have a look at it. Okay, let's go. Sorry, I think I have an issue with. Okay. Perfect. On the other side, sorry, there is an issue with. Okay. So on the other side, we have, for example, if you include, and this again comes from the slides from my colleague team. So this is really important, especially because if you remember, we told you that in the future, the cooling sector in the residential sector will play a very important role. So I really invite you to have a look to this chart. And this, for example, the result of forecasting when including temperature and humidity when projecting AC ownership. And this, as you can, if you remember, because we already touched these topics, including temperature, for example, and humidity, which are context-specific parameters, you can better model and improve the results of the forecasting. Again, here you have the refrigerator ownership with different proxies. So if you remember, Teams introduced you the discriminant criteria. So integrating not only income, but also urbanization and electrification. And in this case, in this way, you will have a better proxy for appliance ownership when doing forecasting. And this is really important. And I will take the opportunity here to ask you, to invite you to try to do actually, if you didn't do it yet, maybe you skipped some of them, the exercises we propose you. So you have the handbook on the Google Drive repository and also the Excel files. I invite you to have a look at those modeling exercises, because they are really important, because you can see what is the approach on each different sector we touched when doing modeling. But clearly, as I always told you, those were just simplification. So those were simplified model in which we had simplified assumptions. And clearly, if you want to do an analysis like a forecast, as the chart we are looking here, which is the refrigerator ownership, but with respect to not just one proxy as we did in the exercise together, but for example, based on a combination of income, urbanization, and electrification, you will see how you will see by doing those exercises, try to have, let's say, to have a critical approach and to see, for example, which other assumptions, for example, first, the assumption we did maybe sometimes were like too simplistic. So try to look at them and to see, okay, maybe this assumption is really impossible, is really unrealistic, so maybe it's better to change it, and try to think about what you could add in terms of additional assumptions when doing the modeling. And if you want, you can write me and we can see together, for example, how you could change those Excel files in order for them to be more realistic with your case studies. So let's continue. So here are, sorry, I have an issue with my internet connection. Okay. So this is historical and projected electricity generation by technology. Which number do you think is Ethiopia? So 1, 2, or 3. Take into account all the different sources and pick which one you think is Ethiopia. Okay, I see one of you answered. Two answers. Take into account really the fact that the axes are different. So you have terawatt hours, but take into account the orders of magnitude. So we have 60, like, yeah, it's the above, but the country on the left, so number 1 is approximately 30 terawatt hours. We have country number 2, which is a bit above 80 terawatt hours. And on the third one, so number 3, is more or less 50 terawatt hours. And secondly, take into consideration the sources, because they are really different. You can see the first one is heavily reliant on gas. The second one is heavily reliant on hydro. The third one is heavily reliant on geothermal and more diversified, I would say. I see 3 answers. Few seconds more. Okay. So I see most of you, all of you actually answered question number 2, answer number 2, and that was indeed the correct answer. As you you may have guessed, the country on the left, no, sorry, on the right, so country number 3 was Kenya. You could have spotted that from the geothermal share in the electricity generation. And on the left, we had Cote d'Ivoire, which, as you may remember, is heavily reliant on gas. But Ethiopia with hydro was the correct answer. You have also solar PV, which is expected in the future to have a really high share in terms of electricity generation. Okay, so here you have electricity annual hourly demand data for 2 northern countries. So associate the right number to the winter peaking and the summer peaking country. So you have two countries, and we want you to associate the right number to the winter peaking and the summer peaking country. So country number 1 and country number 2. Winter peaking number 1 or number 2, and summer peaking number 1, number 2. Take into consideration the fact that this is a whole year, so we are talking about 12 months with hourly demand data in terms of electricity. So this is like the left part is January and the right part is December, and again January and December. So one of them is winter peaking and another one is summer peaking country. So which of the two do you think is the winter country, winter peaking, and which one is the summer peaking country? Very different countries. And clearly, as you may imagine, we are talking about northern countries in this case. I don't see any additional answers, so I will move on. Oh, sorry. Okay, so here you have the answer. So number one, we have during the year, so winter peaking and summer peaking. And then we have, so you can see how this is winter peaking. And on the other end, we had the summer peaking. So it was correct, actually, the answer from the, okay, now we have three answers, okay. Okay. Anyway, you got it all correct, because number one was winter peaking and number two was summer peaking, as you can guess from the chart. And I remember this is really an important chart. So I invite you to go back to the power sector modeling lecture from my colleague Yasmin in order to have a look at this annual, hourly, and but also on a weekly base and clearly daily base. And this is really important. Unfortunately, it's a bit difficult to find data like this on the African continent, and that's why I proposed you in this poll two countries from the, let's say, northern hemisphere. Okay, so now knowing that the red line is electricity demand, is the total installed capacity the yellow or the blue line? So you have the red line, which is the electricity demand. We are asking you which of these two lines, so the yellow and the blue one, is the installed capacity. So yellow or blue. Obviously, we have here two different axes. As you can see on the left, we have gigawatt, so we can see in terms of power, but on the right we have energy, and you have terawatt hours clearly per year. But pay attention to the fact that we have put here the peak to average, so this gap. So if you remind the lectures from my colleague Yasmin, you should find the answer to this question. Two answers. Three. Okay, let's see what you answered. Okay, I see two people answer the yellow line and one person the blue line. So I go back here. Okay, I show you the correct answer. The correct answer actually was the blue line. So this one. Let's see. As you can see, you forgot, the two of you which answered the yellow line, forgot that we have the capacity margin to be taken into account. So you have the electricity demand, the peak to average, through which you calculate the peak demand, but then you have to add the capacity margin, which is the safety margin you take in order to avoid to avoid issues, because you always have to have that the total capacity needs to be greater than the peak demand, which is the yellow line, in order to allow the system to cope with maintenance and unexpected outages. And we call this the capacity margin, and this is really, really important in order to guarantee the grid stability. So let's go to the last question, actually. So global average emissions intensity of oil and gas operations can decrease in the future. What parameter mostly contributes to the drop? So the blue bar. So you have flaring CO2, methane, venting CO2, CO2 emissions from own energy use. So you have the emissions of in terms of emission intensity on an average on a global scale on these two kind of gray bars in 2019 for oil on the left and for natural gas on the right. We have many parameters which contribute to the drop in terms of global average emission intensity of those two sectors in terms of operations to 2030. And you can see how there are different colors, but there is one of these parameters, which is the blue bar, which, as you can see from the results of our modeling, are the predominant. So this parameter is the most important in both sectors, so both oil and gas. Which of these, which of the four options you are given is this blue bar? So I go back to the options. You have flaring CO2, you have methane, you have venting CO2, and you have CO2 emissions from own energy use. Which of these three is the parameter which mostly contributes, or we expect it to mostly contribute to the drop in global average emissions intensity of both oil and gas? Take into account, as you can see, for example, that in natural gas it's almost the entirety of the drop, whereas on the oil sector it is a bit more than 50%. Three people answered. Let's see the answers. Okay, quite distributed. So we have flaring CO2, we have methane, we have venting CO2, we have CO2 emissions from own energy use. I give you a few seconds more and then I show you the answers. Yes. Okay, so the answer is methane. So one of you got it right, and I will show you how they are distributed. So we have this huge drop, which is methane. Then we have flaring and venting CO2 combined. And then we have energy related CO2, which in oil is quite relevant. On the other side, on natural gas is, I would say, irrelevant. So we have governments, industry and financial actors, which are actually increasingly focusing on reducing emissions from oil and gas operations, and methane will be the parameter which will we expect it to be the parameter which will drive this decarbonization, so this decrease in global average emission intensity of oil and gas operations in the next decade, so till 2030. Okay, so that's it. Okay, I will stop sharing and go back just to have, let's say, cover. But that's it for today and for this first phase of this energy data and modeling program. It was really a pleasure for me to be here with you. I hope everything was clear. If you have questions right now, you can clearly write in the chat, raise your hand if you want to directly ask the question or give a comment. You can write in the Q&A box. And so feel free to do it. But in the meantime, I remind you, this was the last webinar in this first phase. So we will, as I told you earlier today, finish also with your colleagues, your peers from Rwanda and Uganda. And once we will be done also with them, we will move to phase 2, and we will you will hear from us very soon, so that we can start planning. Because as I told you, in this case, the training in phase 1 was, let's say, more or less the same for all countries, because this was really just introduction to statistics and modeling, as we are used to do at the IEA, but also how it's done, let's say, for example, in other institutions. And really the idea was to give you an introduction to all these topics. We just changed, clearly, you have seen in many slides, I've put results for the modeling, some modeling exercises on Kenya. In the slide, for example, on Rwanda, I put data from and results from Rwanda. But the idea of the next phase is for it to be really specific for each country. So we will for sure ask you to give us feedback on which is the topic you prefer to address in the next phase, so that we can plan accordingly. I really hope this, let's say, situation with the pandemic and the global environment in general will be easier in the next months, so that we can meet probably in Nairobi and continue with this modeling. And really, as I said, we are 100% available to support you also in parallel with respect to this program. If you have doubts, if you have questions with respect to the slides, to the exercises, feel free to write us, and write me or write to the Africa program email. But yeah, so that's it. I don't know if you have questions, comments. Otherwise, I would close here the session, and wish you a pleasant day and week.